So, Vikrant, I hope you can see my screen, right?
Yes, we can see. You can start your session.
Okay. So, hello everyone. Good afternoon, and thanks Vikrant for your for the introduction. And yeah, hi. I am Saikat Maiti, and I'm volunteer like for a long time for OSM, and I am going to explain like how this open source data and completely free data source you can use for like it can be used for numerous study, but today our focus will be on how we can use this data to analyzing urban pattern, how to use this data for better urban planning, because OSM provides us lots of vector data sets. It is not only the highway, not only the buildings. You can do whatever you want in terms of like features, like you want to map all the utilities using OpenStreetMap data, and you can use that in your analysis for your urban planning, or you can use any data, any vector data format, any vector data for your any project, any application, or any planning, or any drawing purpose. But like it has like a number of probability that we can we will touch few of the things today. So if you are very new to this term, OpenStreetMap or OSM, so I'll give you a quick introduction about that. So the guy who is behind of all this excellent work. So the Steve Coast is the founder, and this complete project is his like bachelor degree project in back in 2004, and after that he opened this project for the community so that anyone can create the data, anyone can contribute the data. So after that, when he opened the project for the community, then it was there is a foundation formed in 26, and after that it is coming with ODBL. Like if anyone is interested about the licensing of any data, they can search more about the ODBL. So currently all the data are available form of ODBL. You know, as a researcher or as a project manager, we always struggle like where we should we can find the data, what is the data source, and where we can curate the data. So these are the challenges. Like if anyone is facing, you can just go to the OpenStreetMap platform, and you can check what kind of data sets are available and what kind of usable data are available for your purpose or for your project. You can take that, just give a citation like, okay, I am giving some credit to OpenStreetMap because they are providing a free data source. Okay. Then why this data is very useful, and how we can use that data. So both we are going to discuss today's session. And if you ask me like, okay, what it can tell us in terms of urban planning or like urban morphology, then we can say that it is very useful for depicting the urban forms, spatial pattern, and analyzing the structure of the road network, understanding what are the resilience and vulnerability for this particular area. Like see, when we are calling that, okay, it will give you a vulnerability analysis, like where the infrastructure are more fragile and more prone to like fail during extreme events like landslide, flood, or any other disaster. So those kind of analysis also can be done using OpenStreetMap data. And yeah, it brings a number of opportunities and endless opportunities from city level to country level if you want to do the analysis. And all the data sources are free to use. So I hope like who are coming from like urban planning, or they are very well familiar about how the urban forms. And you can see the right side photo, like there are 8 cities from around the world. Mostly it is from European and American countries. So there we can see that just seeing at New York, we can tell, okay, it is very well laid plan out. Like if you know about New York, like it was planned in 1811, if I'm not wrong. And after that, each of the grid is like 800 by 200 square feet. So almost 1600 square feet, 16,000 square feet each blocks, and they form a super block, and that is how the planning works. And but how you can analyze uh, this thing using OSM dataset, that today we'll learn. So the next thing is like what like how we are going to use this data, because okay, we are hearing a lot of OSM data and all, but how we can use this data. So basically it is available in very well-known format, that .osm. It is kind of a XML format of the data, so that you can read all the history and all the coordinates of the data. It can be a Geojson file, so you can all the like notation file is geo tagged with the geo coordinate. And if you know about the special format, so .shp or shift file is a very well-known format of the data sets, which is provided by ISRI. And there is another format, like it can be a geo package format, like lots of layers combined into one file, and it is giving a geo package file, so that we can do analysis further. Also geo package file, if you know a little bit about like database, you can ingest any Geojson file into Postgres, and you can use a different layer after ingesting in a database. So what are the popular software like to analyze this data? If I think you all know about QGIS, or you heard about QGIS. It is an open source software like GIS tool, and very powerful tool, I would say, because it is supported by the very good community. And there are lots of plugins you can find for QGIS to processing your data, and to analyze, to get a better result for any urban related study. And ArcGIS, we all know, like this is a very powerful software, but this is proprietary software. And honestly, I don't have the license of use of to use ArcGIS. But this is very well-known software. If you have any student version, or if your university or in your organization, if they have a proprietary license, then you can definitely use ArcGIS, which is very powerful. And also it has lots of inbuilt tool to analyze the thing, like which I told before, like urban forms and all. And Geojson, Java OpenStreetMap editor, the full form of Geojson. So that Geojson is actually very powerful tool to create data for OpenStreetMap. Like OpenStreetMap right now, I'll show you like how that digital map is working. I mean, I think almost 100%, I would say, like in the audience, they use Google Maps some point at some time for some purpose. Okay, so OSM also give that kind of opportunity, but in a different way. And Geojson is helping to curate the data. So today we'll see that what is the backend of any mapping, any digital maps, so that Geojson can give us idea in detail, like how the data looks and how the data is being created for OpenStreetMap. Okay. So there are few library today we are going to explore, that is Osmium. So don't go into the periodic table that Osmium is there. So, but this is Osmium Library that mostly it is coming with the command line interface. And today we are like just check like how the OSMNX, which is a Python package, Python-based library, and it includes lots of powerful library like Panda, GeoPandas, NumPy, and lots of powerful library packaged into the OSMNX module. Okay. So that we are going to check and how it is helping us to analyze the urban forms. There are I scheduled this total like 1 hour time into mostly on the demo session, so that you can see like how we can analyze a large data set for our study, for our like project, because whenever it comes to urban planning, we are not planning entire country, right? Like if I say that, okay, let's do urban planning for India. So first it will come to your mind, okay, first select a city, then I will choose like what are the data sets I needed for that particular city, and what are the things I can do, and what are the things I need to build for that city. So to do that, I think for any urban planner, it is good to have like what are the existing thing we have in that particular city. So let's say I want to develop a new road network to resolve a problem of our traffic in Nashik city. So I should know that what are the existing roads are available in Nashik. So then only I can plan out like what are the new development should come, and what are the things should be changed for the existing network, right? So we should know about that, and the OSM data will help you to understand more than any other just simple photograph or simple uh, like text-based analysis, because we can see the data, we can see where it is laid out, we will see satellite imageries, and we'll see that how it is matching and how it is covering like the data coverage, and how much data coverage is there in my data sets. If there is lack of data sets, how can I create the data? All these things we are going to check out. Is that fine? Any question till this point? Definitely. So these are the few demonstration. We will try this in our scenario. This is kind of a like as I told that Osmium will provide us command line interface based analysis, and we can see like what we can do with Osmium, about how we can do how we can analyze OGR to OGR command, which is actually coming from JEDA library. So this is also like very powerful special library for Python, and we'll see that how can we create a database like we know that Postgres is like supports special database like along with PostGIS plugin. So we will process some data from a big data sets, and then we will ingest that database to our database. Okay, we will ingest that particular data set to our database for further analysis. Okay, and on that we are going to use QGIS. And there is one example I would like to show you guys, that there is one platform. There are a lot of machine learning platform, but there are a lot of important data source you can find totally freely just to after creating your profile, so that how we can download those data, those ML generated data, and how it can help us for utility mapping. That also we will try today. And after that, we'll check some live demonstration on that, how we can quickly check urban layout for a particular area, or for a particular point that we can check, and we can learn a little bit about the like let's say like you need some quick images for your report, and for a layout, how can you create that, how quickly you can create that also we are going to do today. And so this is also another example of Isoline. If you want to know about Isoline, is it means like from a center of a city in first 5 minutes, how far I can travel via car, and next next 10 minutes like from, if this is the city center, then 10 minutes. If I drive, whatever the road I take, I can reach up to this point. Then whenever I'll reach here, it will take minimum 15 minutes. And after that, it will take 20 minutes. So this kind of cool stuff we are going to explore today. And I will try my best to answer all of your question if you have. Okay. So there are a few useful link I would, it is added already in presentation. I think Vikrant can provide you after the session so that you can go and explore these huge data sets. And if you ask me like how to use those data sets, definitely we will learn in these steps. Like we got the data set, that's fine. Now tell me how to use this data. That we learn today. Okay. So till now, if you have any question, I will hold for 1 minute or a couple of seconds so that if you have any question, I can answer till this point. After that, we will move to our demonstration session. If it is not, just gives a thumbs up so that we can move into our next demo session. And yeah. I'm considering that we don't have any question right now. Yeah, we can move to our demo session. And for the demo, before starting the demo session, we'll see that what kind of data source are available. And when I'm talking about OSM, what it is like, that we will see in a minute. Okay. Yeah, thanks, Vikrant. Let me share my screen where we'll do the demo session. And I hope you all can see my screen, right?
Yes.
Vikrant, can you see the green screen?
Yes, we can see.
Okay, cool. Okay, and now let's see like what is OpenStreetMap. So if you zoom out, the complete globe and no data, but if you zoom in, so let's, I hope that most of the folks are from Nasik or the surrounding area. So we can zoom into this area and we can see that what kind of data sets are available. So all these different color, these are different roads. You can see lots of hospitals. You can see lots of green places. There is some stadium, there is some park, there is some traffic island, and lot of other features. And there is a Godavari river flowing. I think it is just middle of the Nasik. It is flowing, and you can see lot of data sets are available. It's a fancy map, right? So let's check how we are like how. I think we all are familiar with this particular map, right? And the lot of things are available in this data for Nasik as well. But you can see that there is no option to download it. If I want to download all this data, we cannot download it very easily, or at least freely. We can download it programmatically. We can use Google API. We can do geocoding and a lot of address stuff we can download. Even I think somehow it is possible, maybe map tile also we can do, but we cannot take it freely. You have to go to Google platform, like GCP platform, then you have to create account, give your credit card information, and after that you have to use their service. But if you come to OSM and let me close it. And if let's say I want to download and I want to see how the data, you can see I have created my profile. So this is my profile, and if you create a profile here, just using your mail ID you are able to download. And for that, we will learn today that Java OpenStreetMap editor. So this is a very powerful tool to use all this pre-analysis, or you can see a lot of data source will come. Let's see that. Okay. Now I just drop down, I clicked here, and I am saying that, okay, I want to see this data in Geojson, and make sure that that time your Geojson should be open, and you can see that nicely everything is available here, and you can see all the information related to this particular selected feature. I'm just using my right click. If you attend any of my session before, like there I have, I think, give one short demo about Geojson. I'm using right click to move this area, and I'm left click to select the feature. You can see everything is available right now. See there, Saraf Bazaar, there is some neighborhood, someone mapped. There are lots of roads are mapped. There is a water body. The river name is Godavari. You can see lots of language are also available. Now, by seeing this, you can analyze the urban form, that how this area is developed, and also it is developing. You can find that very easily, right? And if you are very much familiar with a lot of spatial analysis, lot of uh, processing using shape files, or using road layout, or using buildings, you can see all this data over here. And now you can see that there are no buildings added. So the important thing is here, anyone can create data. So let's say you want to create buildings where buildings are empty. Okay, there are one more thing I will explain here. These are very updated or recent satellite imagery. The company like Maxar, then there are History, Bing Aerial Imagery. So these all companies are supporting OpenStreetMap by serving their satellite imagery type. So these satellite imageries are very high resolution, and you can see like almost everything. Yeah, I would not say that you can see each and every people walking on the road, but you can at least identify the car which is parking, which is on the road. If we go to main road, then there are lots of cars and lot of things you can easily identify using the satellite imagery. It is that much high resolution based on our Indian guideline. I think there are some restriction in India, so you cannot get like satellite imagery like US. If we want to quickly see that how clear satellite imagery in US, you can just zoom into New York, and you can see that how clear it is. But as you know, like we have lots of restriction in terms of satellite imagery resolution. You can, but still, you can see that how US satellite imagery is, everything is visible from the top. But if you come to India for the same satellite imagery provider, we can see a little bit coarser resolution, but still we can do our work and we can curate the data. So first thing first, like if you ask me what is the usage of Geojson in terms of, if let's say you are an urban planner and you need, you want to develop a small area, but you are lack of data. You don't have all the building footprints. You don't have all the road network. You can curate the data over here very easily. Let's say I want to create buildings. Okay. So I have some shortcuts, so I can just press B and start creating buildings. And if you want to see how the data is, like building equals to yes, it is already tagged, and I can create all the missing buildings in this particular area. That I can do, but you can see that it is a little bit time taking. Now, tell me, like, if I don't have that much time, how can I do that? So there is one option, like you can use some programming to create, to generate buildings from the high resolution satellite imagery, but it will come with the cost. It means you have to you have to buy a satellite imagery which is very high resolution. Then you have to do machine learning. Then you need to you will get the building footprint. But if you want to know that is there any data sets who are providing lots of building footprint data? Yes, there are few sites like I'll say. So we all know Microsoft, right? So if I go to Microsoft building footprint data, they have GitHub repository. And if you go to the GitHub repository, you can download the data, like building footprint data for all over the world. And I'm pretty much sure that we have the data sets for India as well. But this page actually typically for the US region, but we have that data sets for India as well. So if you go to Microsoft GitHub page and if you want to search that particular repository, I'll add the link actually in the slide so that you can easily find the which link is applicable for India that you can do. And after that, you can just those data sets are really heavy. Okay, so if I want to split any any large data sets, there is a default command split, and I want to separate that data line by line. And if you want to know like what is the structure of a Geojson file, I'll show you quickly geojson.io. So you can see there are few things. This another one example of Geojson file, but I will clear this and I will create one Geojson file. Okay, so these are the lines. Okay, for one square box, this many line has been created, and I can split the line. If it is very large Geojson file, I can split the line based on that. So that's only I'm writing here. So let's say you have that file which I have downloaded from Microsoft building datasets, and I want to split that file in each and every 10,000 line, or that's based on your computer memory, because you know if you download a large Geojson file or large save file, you cannot process that data, or it will take too much time to process. So you can just split the line. For that, let's say I have some Geojson file in my computer already. So let's try that. So there are few Geojson file I have. It's ing highway Geojson, and you can add some prefix to get all this file name. So if I add prefix some prefix, I can get all the file, and you can see that it is now start processing that particular command, and so it will give me lots of Geojson file from a large Geojson like it is more than 1 GB or it is more than 10 GB. No matter what, it will split all the Geojson file in 10 in like when it will complete the 10,000 line. I think I wrote 10,000 or it is 1 lakh. I think I have written 1 lakh. So anyway, so after 1 lakh line, it will create a new file from this large Geojson file. Okay. But to save our time, I'll kill this process because this is a very basic split function so that we can use that. And yeah, definitely we can use this command to process very large data sets like Microsoft building data sets and all. So there are few other large data sets we can get. There is one more data sets I will show you that you can get whole planet data as a vector file. Vector file means all the features will be available in point, line, and polygon. So it can be used for your analysis, for your urban planning and development. Like as I said before, like for an example, we want to develop a new road network. So I need to know that what are the existing road network available for that particular city. And I will lay out a new road network on top of that. So there will be some prerequisite you can fix. Okay, these are the area where I'll create a junction. So this new road layout will interact with the existing road layout in this particular junctions. Okay, so for that, if I need to, let's say, there is a data set for India, which is almost 1.14 GB, and you can see that every region is divided into different parts, but this format is not like well-known format. Like if you search OSM.pbf, and there are a lot of GIS software like QGIS and ArcGIS. If you directly drag and drop, or if you directly want to open that particular file, you cannot open. Okay, so for that you need some processing, like pre-processing, to use that data. So for that kind of thing, let's say I have downloaded, if I download this data, so it will be almost 1.1 GB, but these are very compressed file. Like if you, after that, if you expand that data, it will comes around almost 19 to 20 GB of data. And I'm pretty much sure, like any open source software like QGIS and also proprietary software like ArcGIS, it will struggle a lot to process this kind of data. So for this kind of purpose, I'll show you some command line like interface that will help you to process the data for your further analysis. Okay, so as I mentioned before, that we are going to use a library called Osmium. And so what is Osmium? So I have, if I just type search Osmium, so you can see that there are a lot of things this particular tool can do. Vikrant, is it visible, like all the text? And
Can you please zoom in on that particular?
Is it fine now?
Yes. Yes.
Okay, let me small window. I hope it is well visible, right?
Yes.
Cool. So you can see a lot of pre-processing we can do. We can merge it, we can filter it, we can create some extract, like there is some extract option, we can create some export, all these things we can do. We can do merge. Okay, we'll see that what kind of things we can use for this particular library. So first thing, let's say when I'll download this data sets, actually it will download the entire India data from this particular website. But you can see it is very huge, and there are a lot of things are available in this, like admin boundary, water bodies, highways, buildings, even like hospitals, temple, mosque, all these things are added in that particular data sets. Okay, but we want, let's say we are interested about the road network for this particular city. So let's say, what is the extension of Nashik? Now, if I see that, okay, I am interested only in Nashik city, and you can see that, okay, this much area, it is pretty large area to start our analysis. Then I want to clip that data from entire India data sets, only highway. How can I do that? And it is not friendly with the GIS readable format. Like, okay, if anyone is experienced here with normal clip, select by location inside the polygon, they can easily say that, okay, we just want to clip, but how can you analyze that data, which is almost like unzip format is 20 GB. Without opening that, we can do that using Osmium. Okay, let's try that out. So our library name is Osmium, and we are going to use some tags filter. So let's say I want to take, okay, I have already that data, INDIA, because I have downloaded the data. I think India underscore. Let me check the file name. I think we can. Okay, so don't worry. So these are the process I started using to split one large JSON file, but I have like India latest OSM PDF. Okay, so let's do that. Osmium. Then I'm going to use our tags filter. Then what is our input? India latest, which is our osm.pbf file. Then I am going to use all the highway. Okay, so highway as I'm telling you, this is a vector data format. So that is available as a way, like which is actually line string or line feature. Then I'll use highway. Okay, then I can take the output, which is -o. Then I can say that, okay, give me all the highway. Obviously, we cannot export it as a Geojson directly. And then we can just export in .osm.pbf. So now from, I think I did a typo. So now from the entire India data sets, it is giving me only the highway, which is already tagged with highway. So now what I'm saying that already tagged with highway means if we click this, it is, you can see the key is highway. Okay, so that's why I'm saying that, okay, give me all the features which is the key is highway. Okay, then it will give all the classification. Now this is another filtering technique I have used. So I have right now India -highway. I think I added India underscore hyphen highway. Okay, that's weird. So okay, this file I have created. Now I am only interested for Nasik. Okay, from this highway data. So how can I do that? I'm still not opening the file. Okay, I don't know what is happening, but let's try that out. So I want an extract. So I want to extract what based on the Nasik boundary file. So what I have done before, I have QGIS and I have downloaded some admin boundary, and so this admin boundary I got, and I have extracted the Nasik Geojson boundary so that I can use this Geojson file to do some extract or to do some subset from our large data sets. Okay, so I'll use that file. So that file should be Geojson file, and I'll give the input file now. So the input file is the weird way. Okay, so this is our PBF file. Then I'll give that output file name, so which is -o, and let's say, okay, all five. This is Nashik highway. Now the format will be same, OSM.pbf. Okay. The process is done. You can see that how fast it is happening when we are just processing in this. Now let's take a quick look of this highway export, what we got over here. Okay. How can we do that? Now, first we have used the tag filter. Remember this thing. This will help you to actually understand. So first we did the tag filter and we took height. Then we took an extract for Nasik. Then we are going to convert this file from OSM .osm.pdf to Geojson so that we can see that the data and we can do further processing. Okay. So for that, it is a very simple command. Just go to Osmium. We are going to export this data as a PVF. So let's take Nasik highway.osm.pvf and we'll give the output, and output file name will be like we want to create a Geojson file. Nasik highways.geojson. Now you can see the file is the processing is completed. Now let's say we have a lot of other file. Let it be. Now let's see that where is that file? Nasik highways and Geojson file. So it is from 1 GB like zip data. It is created like 16 MB data sets. Okay. So now we are going to add the layer. Now we can see that whatever we are seeing over here. So I think you all know this particular highway, and this particular highway is crossing through Nasik. Let me increase the width of this. So the same thing is coming over here. What we can see in this particular area. And if you see, this is tagged with highway secondary, or let's select this one. This is trunk road, and the same format we can see over here, which is trunk road. If I take this info and if I select here, we can see all the attribute and lots of other attribute. We can see that, okay, this is Mumbai Agra highway, and there are lots of things we can do over here. Now, let's say in our old method, we have like Nasik boundary. Now we want to make a clip. Okay, let's remove our previous one. Now I want to create a subset using this particular admin boundary, and we want to clip the data. Just to clip, and the input layer will be Nasik highways, overlay layer will be type boundary Nasik, and select selected feature, and run this one. Now you can see it is creating a clipped version of this particular data sets, and now I am getting an idea of that how this Nasik road network is laid out in this particular city. So for an urban planner, now I know all of my data sets. Now, if I want to create a logic behind this, okay, wherever the main roads are going, I want to lay out the new road network, and I want to know that what kind of land acquisition I need to make, and what are the land uses I need to consider. Like, we can do all this stuff. If it is not available in OSM, you can create your own data sets, as I showed before. Like using Geojson, you can create all the farmland and all the vegetation and all these things. Then you can get an acquisition area like based on the land use, or you can use any third-party land use data who will provide all the land use data sets for Nasik, and you can do the further analysis. But you can see the basic analysis for a large data set. How can we filter the tag, and how can we use that data further? You can use this Osmium library to filter it out. Okay. Now, if you want to see that, okay, what happened to that complete data sets which we have done for this in our first step, like we took all the OSM data and we took only India data sets. Let's see that data set, how it looks. As you know, this is very high data set, heavy data sets, like it is almost, what is the memory it is showing? Like all India data sets, it is showing like 3.53 GB, only highway. Okay. So that data sets, right now we are trying to open and it is taking time. Okay, I think it is taking some time. Let's do one more thing. Sorry, it completely stuck.
So meanwhile, can I ask for
like very important thing for urban forms about this cool feature about one very powerful tool which is called OSMNX, and you can see that this is a one library and this is a Jupyter notebook. You can easily install that library inside the Jupyter notebooks. And I want to create one image which is PNG format, and size I have defined that 600 by 600, which is 150 dpi image, and I gave Nasik, and I took a center point like from where this image can be created. So this will help you to understand the urban morphology. So if you run this line of this piece of code, you can get one black and white image of this, and the same images can be like what someone asked the question, like what are the road attribute we can get from this data. There are a lot of road attribute you can find, which are primary road, trunk road, secondary, tertiary, unclassified residential, and you can create, you can see this every width the same, but here the trunk road has wider, and the residential road is less wider, unclassified, and service and footpath is narrower. So you can do a lot of design and you can create some cool image like this. Okay. So you can use any to study, you can do this to study any urban morphology. Okay. Then another thing is that about the isochrone. So what is isochrone actually? Isochrone is like in a certain time period, how far you can travel from a city center. So there is a logic, like there are few imports you need to make, and let's say I told, okay, from the Nasik city center, which is in Maharashtra, give me all the drivable path. So drivable path means the road is wider than 3 meters. Okay, and 5 minutes, 10 minutes, 15 and 20 minutes, and I have considered the approximate vehicle speed is 40. Based on that, how far we can travel. So first, using the graph theory, if you remember your graph theory, the graph theory chapter, like there are all our node and edges, right? Using the node and edges, how far we can travel using this time with 40 kilometer per hour average speed. And we can create some cool diagram, and you can present, okay, if I start traveling from here, we can travel in first 5 minutes, then next 10 minutes, next 15 minutes, and in 20 minutes till this point, up to this point inside the Nasik. But yes, this is not considering any traffic data, like live traffic data. So, but this is a pre-assumption just to design your urban layout or just to design your planning. On top of that, you can add the weightage of live traffic and other stuff. Okay. This all the snippet, I'll make that available for Vikrant so that you can refer this kind of snippet later. Okay. Now let's check the QGIS. I'm really sorry that is not happening. Let me try one more time. So let's minimize everything and check. No. Better I can kill this, but I will show you the table. Okay. Who asked me the question? Then, so what Vikrant you asked to show about the 3D buildings. So you already heard about the OSM, right? And you can see there are few sites you can, if you are interested in 3D mapping, and let's say you added all the buildings in Nasik and you added the height also, height attribute for that particular building. If you want to add height, like, okay, I have drawn few buildings, right? And I know there is some government hospital, and this government hospital building height is, let's say, okay, so this government building height is, let's say, 30 meter, means not 30 meter, like 3 into 4, let's say 12 meter. So whatever you will add, it will be in like in meter. So if you add this kind of information and if you upload the data, there is on upload, so it will upload into the OSM server. Okay. After that, you can visualize this building over here. So there are few 3D buildings available in India, and there are a lot to come. So we are asking you if you know any area where 3D buildings are there. So I know some area where I have mapped few 3D buildings, and you can see that how it will appear in this kind of server. Like this is called A4 Maps. You can use this API to use to incorporate any of your application. So you can see that how detailed we can lay out one 3D building. And if you just move, like you want to add the color, you want to just you can see the roof shape. It is different. This roof shape is flat. There are other roof color and the wall color. Everything you can assign in OSM, so you can see this thing in 3D data, 3D data assets. Okay, and the 3D visualization will come in particular this site. Also, there are few famous buildings like Mysore Palace, the Taj Mahal. So I want to show you the Taj Mahal. That is also pretty cool. And that is in Agra. So let's go to Agra. And Taj Mahal, we all know, just beside the Yamuna. And if you come here and you can see that how this Taj Mahal. So all the thing is mapped using Geojson in OSM. So after that, there are particular CGI, which is computer generated architecture. So based on over there, you can find all this kind of cool stuff. Okay, so let's say you have decided that you want to create a 3D city for Nasik, and you did a survey, all the building height, you just feed the data in OSM, then upload that data in OSM. Like, okay, I have added 3D information. If I want to upload this data, I can upload this data. This kind of things will come. But just feel free to check one of the previous OSM workshop. I think Vikrant has the recordings. Maybe you can check over there that how can we upload the data in OSM. And after that, if you check over here, after some time, you can see that this is updated in a minute or sometime in a day, if it is a large data set. Then you can see all the things in 3D in particular website. Okay. I think we are like over the time, but let me show you the attribute what we have processed. Okay. So for this, I'll take a very small file so that we can see what actually happened in the processing and how the data. Okay, let me. So I just quickly created one small file. By the way, I think I took that Nasik boundary, the complete Nasik district boundary. So that's why there are a lot of data sets added. Now, let me show you the attribute table and what are the types of highway we can see over here. Okay, the attribute table is coming. And you can see how detailed these data sets are. And there are lots of tags. So can you, Vikram, can you tell me the name who asked this question?
Bharti.
Bharti, you can see under highway, you can see all the different type of highway over here. Okay.
Yes,
And
yes.
yeah, if you want to color code it, you need to go to layer style and you can just change to category and just classify it. So if you hit classify button, so all the, okay, I think I need to select this value and select highway, classify it. Just remove this. And now you can see that all the highways available and different type of highway, you can color code it. Is this helpful?
Yes, sir.
Okay, cool. Now, Vikrant, can we take few questions if anyone has any question? Like, Vikrant, if you heard about.
It's Mapillary, okay.
Yeah, it's Mapillary. Let's say go to app. Now, what this data source, they opened it. So let me go to the area where I know there you will get some data. So let's say utility mapping. I told about one of the application is utility mapping. Okay, so there are street photo where I can see lots of utilities are available, right? This electric pole, this light post, all those things. These are part of utility. Okay, and sometimes manhole also utility, but you know how difficult to get this data. So if you have an account in Mapillary or if you create one account in Mapillary, just go here and search the utility you are searching. If it is coming under their machine learning algorithm, you can get that data. So I want all the utility pole. Okay. So if I come here and if I just zoom out little bit, you can see their machine learning algorithm already detect lot of utility data. Okay, so these all are light post, and you can see the validity. Like if you click this image, it will automatically show that segmented classification of a utility pole. It is deriving as a light post, okay, or utility pole, and you can validate through this particular imagery, which is like a street view kind of a thing. And if you come here and you just hit download button, and I want to get all this data in Geojson format. So I'll add Geo. Now it will ask, okay, use Geojson. Now let me open this data source in QGIS or in Geojson. Let's zoom to that particular layer. Now if you open that, and you can see that what are the data source and everything, you can see these are utility pole. And you can check from where exactly it is falling. It is a pretty usable data source, I think. And if you just enable the satellite imagery layer, either from Google, or there are few things like ISRI world imagery also we have, like ISRI satellite. Let's add ISRI. And you can see that where these utility poles are falling. So let's say any urban planner, they want to collect all the utility pole data to do some further development planning or something. They need to do a mapillary survey in that particular area, then upload those photos into their server. This server will automatically process that data based on the collected photos like this, and it will give you a vector point layer for this particular feature. Okay, and you can see all the features. Like if you just mention all points, I don't want bifurcation, even they will detect dustbins also. Like for urban planner, I want to know that where already trash cans are there. So I can see that. I'll show you one quick example. Like if I click on the trash can, it will show me that that identification, like where that trash can is located. You can see there is a trash can, right? Did I share my screen, or Vikrant, is it visible?
Yes, yes, it is visible.
Okay, okay. So you can see the trash can, and you can see that how intelligently it is located through this algorithm, and you can download all the data sets. So yeah, I hope that this kind of data sets will help you to do further analysis in